Today we're going to talk about the four types of database bottlenecks. And to be honest, this is probably the least sexy video I could do because there really is no cool way to teach it or show it other than to give you a couple PowerPoint slides about it. However, this is a fundamental in my view. This is something that you need to know so you can actually triage or troubleshoot a server that's in pain. If you don't know what to look for, you have no idea what to do when you get the page out at 3 o'clock in the morning. This will get you there. And it's going to act as a springboard for another video or two where we're going to talk about how to look for problems within the database server. We'll end up going into something like the summary reports and how to tear them apart. And then I'll show you a very cool script that is pretty much done, but in peer review, that does a lot of tricks when it goes out and does an autonomous check of the database server and give you a report of what the problem is. But before we get to all that cool stuff, we got to cover the fundamentals. So let's talk about the four types of database bottlenecks. When you're troubleshooting within the database, there are really only four choke points. Well, there's another one that I'm kind of throwing in, which I'll explain later. But in the end, it's usually one of four culprits: CPU, disk, memory, or locking. Now, before I get too far into this presentation, I need to point out that a lot of what I'm about to show you is heavily sourced from a best practices documentation that was written by Steve Rees. It, to me, is one of my Bibles. It's one of two or three PDFs that I have on my computer at all times. It has really in-depth analysis on how to troubleshoot and how things should behave within DB2. I'm going to put a link to it within the description of this video underneath the video, so go check it out. The first type of bottleneck is disk, and you're going to see it in one of two ways depending on what type of tool you're using to observe it. It's either going to come across as disk utilization is unusually high, up and over 80% and holding there, or it's going to show up as high I/O wait time for something like the CPU. Now, what could be affected here? What disks do I need to be concerned about? The first thing that a lot of people think of is, hey, the disk that my data is on, and that's definitely true. But you also have to watch out for the disk that may be holding your DB2 active logs. If that's getting pounded, that can slow you down as well. If you're looking at it or you're alerted off of the wait time, what do you know? Where's that threshold? Where do I become a little panicked or concerned? And the general rule of thumb is when you're hitting about 30% of your I/O wait time. When that's happening at the disk level, you know that there could be an issue. And if your CPU seems to be underutilized or is a little lower than it should normally be, and that's happening in conjunction with a high I/O wait time, you know that this really could be a strong lead. So how can you find it? Well, one tool that's always available to everybody is IOstat. It's on Unix and Linux. It's very simple to use, and you essentially tell it how many times you want it to run and how long you want it to run. So it will go through and say the interval is 2 seconds. It'll do a 2-second interval 5 times and show you the result each time. What you would watch out here is the average CPU. It will tell you what the percentage of I/O wait time is on disk, and it'll also tell you if your CPU is idle or not. Some interesting information below is exactly how the disks are doing. What's my read and my writes and whatnot. I wouldn't get too concerned or get into the weeds with those metrics. You could lose your mind chasing a rabbit hole. But knowing the normal TPS, what is your I/O request to the device, that could be useful later on. But you would want that in context of historical information. The next bottleneck is going to be at the CPU level, and this could be at CPU saturation for all of the CPU or just a single part of the CPU. And this can be misleading when you see it for the first time on a server. We all probably know this, but just in case, when we talk about a CPU, a single CPU, you can go back to, the old school computers that you had on your desk 10 years ago. You had a single CPU and it was your brain. And if that CPU is working too hard and became saturated, things could slow down. On a server, you could have multiple CPUs, and those CPUs could have cores or threads. So it gets really confusing when you pull it up in a monitoring tool. So let's say it's something simple like a development box that has a single CPU but is 4 cores. When you pull up the metrics to look at it on the computer or on the server, what you may see is it looks like it has 4 CPUs, where it's actually a single CPU with 4 cores. But what you're watching out for is, are all of them getting saturated and pounded, or is maybe one core being pounded out of everything? And the other thing to watch for that I think is very useful is what's the ratio between system utilization and user utilization. If you're taking a look at that and it's 3-to-1 or 4-to-1, that's not uncommon. It's when you're getting beyond that that you can grow concerned. Finding CPU utilization can come about a couple different ways. The VM stat, again, is something everybody has. You give it an interval and a count, and it will give you a lot of information. It's not just CPU. The area that we would be concerned about is at the very end here, where it's going to start showing you things like the percentage the CPU was idle, or the percentage the CPU was waiting. Here it obviously has no problem. One of the things that I like with this output is it is also going to show you the memory and swap. And memory and CPU often go hand in hand. At a database level, sometimes when you have a change in behavior with the SQL, for example, let's say I gave myself more buffer pool. Well, now all of a sudden we can do a lot more work in memory, and it's 10 times faster than when we were going out to disk. Well, if we're hitting our memory hard, the CPU can start speeding up because it's doing more work for you. And so a ripple effect happens. The memory starts getting used quite a bit, so the CPU is going to compensate and be used more as well. That's why I'd like to see them both there. The next is memory. Memory, in my opinion, as an experienced DBA, is probably the hardest thing to observe, know when there's a problem, and when to react. A lot of it comes with just wisdom of being on different types of systems and knowing how memory reacts to DB2 under certain workloads. In this case, memory will become a bottleneck when allocation is usually too small. So if it needs to flush out things to disk because the allocation is too small, well, it's going to slow things down, right? I've got to stop and write what I'm doing down to disk. If I have a small buffer pool and I can't pull enough up into memory, I'm constantly going back down to disk. So memory allocation can be done at the instance level and at the database level, and there are a bunch of different things that can be tuned. So again, it's kind of hard to chase down, but what's the symptoms? How do I know there may be an issue there? Well, what I look for is swap space. When I see that swap space is being heavily used, I can usually see that there's a bigger overall problem. It may not be DB2 necessarily. There might be something chewing up memory on the server, but I know there's a problem. Swap space is usually an area of allocated disk that the server treats like its memory. So if it is using its memory and it needs more, it may write down what it's doing over in disk, like it's keeping notes. And if it has to keep chewing that space up, we know that your memory isn't enough for the workload that you're doing. So if swap space starts to increase, we know that things may not be allocated right. And if you're seeing swap space climb up and the CPU is relatively low still, that's a sign of memory pressure. There's a good tool that I like to use over VMstat, and that's Top. Top is again available on Linux and Unix, and it shows a lot at one time. Up here, remember, I'd like to use memory and CPU in conjunction with each other. So I can see my CPUs at 99.7% idle, and I am not waiting on disk. I can see what was allocated for my memory and how much is used and what I have free. But I also can take a look at how much space was allocated for my swap and how much is used. Do I need to be concerned? If I see my swap space is going up quite a bit in the use category, or my cache is starting to get out of hand, I know that I may be having a memory issue. Now, one of the most useful features of this tool to me is the fact that it'll show you your top processes. By CPU and memory. So you can go in and see, hey, 50% of my memory is being used by Splunk, or hey, 50% of my CPU is being used by DB2sysc. You can see what is chewing things up at that moment in time for you. In my opinion, it's a lot easier to interpret and quicker to see in context. The last is the lazy bottleneck. So this is a case where you're not seeing pain elsewhere in the server. The server seems fine, disk, memory, CPU, but you're just not producing enough. You're expecting a faster response time. You're expecting more data to be pushed through as you need, and it's not happening. And that could come from a couple different areas within DB2. You could have lock contention. For example, application server A is waiting for application server B to finish its work so it can come in and get things done, or the application server could be locking on a table that has maintenance going on at that time. You could be dealing with prefetching or poor page cleaning, which is when DB2 is working within memory, but it needs to be flushing things out so it can bring new information in effectively. Or it could be the application, and this is me adding it here because sometimes we try to make worst case scenario. And I've gone in going, man, we're just not producing as much. What's going on? It's got to be a lazy bottleneck. And I found out, no, it's just the application stopped sending information. So as silly as it seems to add that, sometimes it's the simplest thing that you need to check out. So how can I see these bottlenecks? If you are basically on 10.5 or 11, well, DB2 top, in my opinion, is where most DBAs go right now. DB2 top is actually deprecated as of 11.1, which means that they're not working it on anymore, but it is there. It's being replaced by a tool called DSM top. But I still personally use it because I haven't been on 11.1 long. If you go in and pull up DB2 top, you have two cheats here. The first is locks. If you hit the capital U, it's going to show you at a refresh rate of like every second or something like that, 2 seconds. It'll refresh the screen with what it's seeing. So this is real time. It's not an observable period that has a beginning and an end. This is, if I sat and watched the box every 2 seconds, this is what's going on. You have to know how to interpret some of this. I mean, for example, here's the agent that's coming in and where it's coming from, what it's doing, and you have your lock mode. Now, lock mode has a bunch of different settings. You have X, IX, S. You've got a ton of different types of locks. And that's up to you to look at and know which ones are important and which ones can block you. For example, an X would be an exclusive lock. That could block things out. But if you need a cheat and you're wondering, well, am I blocking anything? You can hit L for lock chain, capital L, and it will show you what application or agent is blocking out another. So for example, 38 is blocking out application 40. If I went in and ended up forcing off 38, suddenly 40 and 46 could work itself through. There's also the capital B for bottleneck, and that is taking a look at everything within DB2, from locks to sorts to logs, anything that could be a source of contention is here. Now remember, this is refreshing every 2 seconds, and also it's real time. So if you see something in the 90s, don't panic. Watch it a minute or two. If you're in the 90s and holding in the 90s for 2 minutes, yeah, go focus in on it. But you will most likely see these numbers are bouncing all over the place. One area could be 99% and then drop to 2, and then it can go back up to 60 and then down to 5. So take it in context over an observable period that you're in front of the screen. Finally, something I consider an atypical lazy bottleneck would be the table space state. This is not anything preached by Steve Rees, but this is something that I personally watch out for because the behavior can be like a lazy bottleneck. And that is a case of why are we not pushing through as much as we normally would? But it's also a matter of we're getting intermittent response. So this could be a case where one user is operating fine where another user is not. One application server is firing off all different types of queries, but only certain ones are failing. And that can be because your table space state is locking you out. So if you have a vendor database, most likely all of your tables are in a single table space. And if that table space went bad, everything comes to a halt. But if you're in a data warehouse or you're in a heavily transaction processing database, you may have 5, 8, 10 table spaces and your tables are broken up among them. So if only one of those 5, 8, or 10 table spaces end up having a problem, only the SQL hitting those will be a problem. So it looks very intermittent, like you have a problem or you don't, or you can't duplicate it all the time. This will happen when your table space state goes into something like backup pending or quiesced, or it's just not accessible. In the lower environments, I can have a developer do a load improperly and now it's waiting for a backup before it can move forward. You can have a tool that will quiesce the table space because it needs access but then doesn't give it back. Or if you actually have a container or disk level problem that's linked to a specific table space and that disk goes bad, that table space goes bad. The way I look at it is I have a quick and dirty SQL that would run every 5 minutes in cron. I actually converted it to be a hook for Dynatrace that was linked to my page out system in my email. But it's really simple. Basically, you can go out and look at MonGet table space and see what state it's in. Now you have to know what to ignore. If it's in normal or backup in progress, load in progress, reorg in progress, I really don't care. But if you have any state other outside of that, you could be in a state that could block out work. So at that point, I alert. Now, if you go to my Discover DB2 GitHub account. That's actually my GitHub account, but there is a Discover DB2 section there. You'll actually see a couple hooks that you can download for free, and one of them is the catching table space state. So hopefully you will find that useful. Well, that's it. We covered the 4 types of database bottlenecks, and maybe a 5th one if you count what I threw in there. If you haven't already, I encourage you to go back and take a look at my video on the DB2 error log and on locking. If you end up looking at those 2 plus this video, you'll actually have a really good basis for troubleshooting your own servers. Well, that's it. Thank you for watching, and I'll see you soon.